we're interested in the soil types. So what we have here are soil sensor layers. So the reason the farmers want to collect these is to try and define where their soil types change in the field, and then to try and assess what it is that makes those soil types different, and then how they might manage them. So what we're interested in here in this particular farm is targeting our potassium inputs better. But just to sort of start with, to give you an idea of how the soils might vary, is this area in the corner, which is a very low radiometrics potassium values. That's the soil type which is apparent in that area. So, you know, gravelly ironstone gravel on top and running into some fairly heavy conglomerate. And then when we get down to this area of the field over here, we've got this dark area and this light area. So down in this area here, this is this soil type. This is this sort of grey soil type, and then on top of the ridge is the red. You can sort of see that line there. So that soil on the ridge, that looks like that. And the soil down on the grey area down here, that looks like that, and they're virtually side by side. So what we do with the soil sensors, I'm just going to put the EM map on top now, and what the EM map does, it virtually has measured where that edge is between the soil types. So that red sort of coloured soil, this one is sitting up on top of this area here. And the grey soil sits on here. So effectively, the soil sensor, what it's trying to do is take the paddock, measure where those changes are, and put it into a desktop computer, so then we can start to analyse it and work out, you know, where we would like to put our different rates. So the final outcome of this here with this paddock was variable rate potassium. So once they went around and analysed it with the soil tests and so on, they built up some knowledge about which soils needed potassium and which ones had sufficient. So then what they did is they brought in another overlay here. So what this map here is, it shows us where they put 0 rate in this soil here, which was that red-brown earth, this one here, which had adequate potassium, and then they put up to 30 kilograms in this area here in the blue corner, because that was lacking. So through the soil sensors, I guess they're able to define where those soil types change, understand their chemical and physical characteristics, and then sort of target their inputs accordingly. So in one of those, or a few of those photos, there's actually colour changes across the farm, and lots of fields where you can see the reds, the greys and the white sort of soils changing. Yeah, it's very long-lived information if it's done properly and it's soil cored and analysed. It has incredible longevity, because it's not something that's likely to change. So it's one of the fundamentals of understanding the causes behind yield variability. So if we understand our soil changes and where it holds water, where it's got constraints and chemical properties that aren't favourable for plant growth, well then we can start to understand, you know, what's a likely cause behind the yield variability and can we manage it. So it's one of those things that, whilst it's quite an involved process to start with, well, relatively, it only has to really be done once.